Take a deep breath and let the weight of the day begin to lift. As you settle into this quiet space, find a position that allows your body to feel completely supported, as if gravity itself has become a soft, warm blanket. Tonight, we are leaving the noise of the world behind, drifting away from the familiar glows of our cities and toward the silent, copper-hued horizons of another world. We are traveling to Mars, to a vast and ancient plain known as Utopia Planitia. Here, amidst the frozen dust and the long shadows of dormant volcanoes, a lonely traveler has uncovered secrets that rewrite the history of the Red Planet. Before we begin our descent into these Martian mysteries, I invite you to join our quiet community. If these journeys into the stars help you find peace, please consider subscribing to the channel. Your support is like a distant star that guides this project forward, allowing us to keep exploring the wonders of the cosmos together. A simple tap on the subscribe button ensures that whenever the universe calls, you'll be here to listen. Now let your breathing slow. Imagine the air around you becoming thin and cool, shimmering with the faint light of two small moons. For billions of years, Mars has kept its stories locked beneath layers of iron-rich sand and frozen stone. We once thought of it as a world that died young, a place where the water vanished and the heartbeat of the planet stopped long before life could truly take hold. But recently, a new messenger named Zhurong arrived on these silent shores, equipped with eyes that can see deep into the ground. What it found in the silence of Utopia Planitia was not just dust, but the memory of waves, the echo of ancient floods, and a timeline of water that lasted far longer than we ever dared to imagine. As we drift deeper into the night, let your mind wander across the rust-colored dunes. We are going to explore the shoreline of a sea that hasn't existed for an eternity, feeling the stillness of a world that is not dead, but merely dreaming. Close your eyes, let the cosmic hum fill the space around you, and follow me into the red silence. Chapter 1. The Awakening of Zhurong. Take a deep, steady breath, and as you exhale, imagine the silence of a world that hasn't heard a human voice in 4 billion years. We are standing on the edge of Utopia Planitia, a vast frozen expanse on the northern hemisphere of Mars. The air here is thin, a ghostly veil of carbon dioxide that shimmers with a faint, pinkish hue as the distant sun begins to climb over the horizon. The sun is smaller here, a pale lemon drop in a deep indigo sky, providing just enough light to illuminate the fine, rusted dust that coats every rock and every hollow of this ancient land. In the center of this stillness, something is stirring. It is a small geometric shape, a visitor from a world millions of miles away, beginning its long, slow awakening. This is Zhurong, named after the ancient Chinese god of fire. It carries the warmth of human curiosity into the biting cold of the Martian desert. For months, it traveled through the terrifying vacuum of space, tucked safely inside a protective shell, waiting for the moment its sensors would feel the brush of Martian gravity. Now it sits motionless on its landing platform, a silent sentinel in a desert of iron and stone. Imagine the mechanical patience of such a machine. It does not feel the bone-chilling cold, which drops far below freezing as the night retreats. It does not feel the loneliness of being the only active presence for thousands of miles. It simply waits for the first rays of sunlight to touch its solar wings. As the light creeps across the plains, the gold-tinted panels of the rover begin to catch the energy of the sun. It is a slow, quiet process, the conversion of light into life. Deep within its titanium frame, currents of electricity begin to flow like a gentle pulse. This is the heartbeat of exploration. One by one, the rover's systems blink into existence. First, the heaters activate, warming the delicate electronics so they don't shatter in the extreme cold. Then, the computer processors begin their self-checks, a digital internal monologue that ensures every joint, every camera, and every sensor is ready for the journey ahead. There is no rush here. On Mars, time moves differently. The days are slightly longer, the shadows are deeper, and the silence is absolute. Imagine the sound of the first movement. In the vacuum-like thinness of the atmosphere, sound doesn't travel well, but if you were standing there, you might hear a faint, high-pitched hum, the sound of tiny motors overcoming the friction of the dust. In the rover's mast, its head begins to rise. It moves with a deliberate, rhythmic grace, unfolding until its panoramic cameras are level with the horizon. This is the first time these eyes have seen the Martian sky. The cameras pivot slowly, scanning the 360-degree landscape. To the north, the plains stretch out forever, flat and featureless except for the occasional ripple of a sand dune. To the south, the faint, jagged outlines of ancient craters break the skyline. Everything is a shade of butterscotch, ochre, and deep crimson. The dust is everywhere. It is as fine as talcum powder, a remnant of 1 billion years of erosion. It clings to the rover's limbs, a thin coating of Martian history. Zhurong doesn't mind, it is built for this. Its 6 wheels are designed to grip the treacherous soil, to navigate the hidden rocks and the soft patches of sand that could trap a less careful traveler. But before it takes its first step, it must communicate. It points its high-gain antenna toward the sky, searching for a tiny moving dot among the stars. The orbiter circling high above. A beam of data, a digital hello, is sent upward, traveling across the void back to Earth. On our home planet, scientists wait in hushed rooms, watching their screens for this single bit of information. When it arrives, it is a moment of profound connection. A bridge has been built between 2 worlds. But here on the surface, Zhurong remains in its meditative state. It is not a creature of emotion, yet there is a poetry in its solitude. It represents the pinnacle of our reach, a physical extension of our desire to know the unknown. As the morning progresses, the rover begins to test its instruments. It flexes its robotic arm, a slow extension into the thin air. It calibrates its laser, which will later be used to vaporize rocks and sniff their chemical composition. Every movement is a celebration of precision. Think about the stillness that surrounds this machine. Utopia. Planitia was chosen for its flatness, its safety, but also for its mystery. Billions of years ago, this place may have been the floor of a great ocean. Now it is a graveyard of windblown sediment. The rover sits atop a landing platform that used a combination of heat shields, parachutes, and retro rockets to arrive. The scorch marks from the engines are the only scars on this pristine landscape. Zhurong looks down at the ramps, the 2 metal tracks that will lead it from its cradle down to the actual soil of Mars. This is the final threshold. The descent begins. It is a movement so slow it is almost imperceptible. The wheels turn a fraction of a degree at a time. The rover inches forward, its weight shifting as it moves onto the ramps. You can almost feel the tension in the metal, the quiet creak of the joints as they take the strain. And then the moment occurs. The front wheels leave the metal and press into the Martian dirt. There is a soft, muffled crunch. For the first time, Zhurong is truly part of the planet. It leaves behind a pattern of treads, a signature of humanity written in the dust. As it moves away from the lander, Zhurong becomes a true nomad. It is no longer tethered to its arrival point. It is free to wander, to look behind every rock and over every rise. The sun is now high in the sky, casting short, dark shadows. The rover stops to take a selfie, a tradition for our robotic explorers. It extends a small camera and captures its own image, a splash of silver and gold against the endless red. It looks small perhaps, but its presence fills the silence with purpose. This awakening is more than just a mechanical startup. It is the beginning of a story that will change everything we thought we knew about the water on this planet. Every meter the rover travels, it is walking over secrets buried deep beneath the surface. It is not just looking at the rocks, it is feeling the ground beneath its wheels, using its radar to peer into the dark layers of the past. The journey is long and the pace is slow, but in this quiet corner of the solar system, a great discovery is waiting to be found. As the rover settles into its first full day of exploration, the light begins to change again, casting long, golden fingers across the plains. The wind picks up slightly, a gentle whistle against the rover's chassis, carrying with it the scent of iron and the cold of the coming night. Zhurong stands still, its sensors drinking in the environment, preparing for the vast solitude that defines this world. The horizon calls, a thin line where the red earth meets the black of space, and the rover is ready to follow it. The silence here is not empty. It is a heavy, ancient presence that seems to watch the rover's every move. As Zhurong prepares to navigate the first of many dunes, it is entering a landscape that has remained unchanged for millions of years. For every ripple in the sand is a record of a wind that blew before humans ever walked upright. To move through this place is to move through time itself. The rover's wheels create the only new shapes in this world, a temporary trail that the wind will eventually erase, returning the plains to their eternal, undisturbed state. But for now, the trail remains. It is a path of curiosity, a path of science, and a path of peace. As we leave the rover to its quiet work, we begin to realize that its physical journey is only half the story. The true exploration is happening beneath the surface, where the echoes of a much wetter, much more vibrant Mars are waiting to be heard by the sensors of our golden traveler. The ground beneath those 6 wheels holds the key to a mystery that spans billions of years, a mystery that begins with the very ground Zhurong now calls home. As the rover moves further into the heart of Utopia Planitia, the landscape begins to reveal subtle shifts in texture and tone, hinting at the complex history hidden just out of sight. The flat plains are not as simple as they first appeared. There are strange polygonal patterns in the ground, similar to the frost-heaved soil found in the Arctic regions of Earth. These shapes suggest that the ground here is breathing, expanding, and contracting with the seasonal changes of the Martian year. Zhurong moves toward these patterns with a slow, mechanical grace, its sensors already humming with the anticipation of what lies beneath. This quiet transition from the landing site to the unknown territory ahead marks the true beginning of its mission. As it prepares to peer through the dust and into the very soul of the planet, Chapter 2. Solitude in Utopia Planitia. As the last echoes of Zhurong's landing platform fade into the thin Martian air, a new kind of silence settles over the northern plains. It is a silence that feels heavy, layered with the weight of millions of centuries, where nothing moved but the wind and the slow, rhythmic shifting of the stars. Imagine standing there, beside the rover, as it takes its first full measure of this environment. Utopia Planitia. The name itself suggests a perfect, peaceful place, an ideal landscape, and in many ways it is. It is a vast open basin, one of the largest impact craters in the entire solar system, so wide that the curvature of the planet hides its distant rims. From where Zhurong stands, the world is perfectly flat, a butterscotch-colored sea of frozen dust that meets the indigo sky in a sharp, sun-unbroken line. There are no trees to rustle, no birds to cry out, no water to lap against the shore. There is only the soft, low-frequency hum of the rover's internal cooling fans, a tiny heartbeat in a world that has long since forgotten the sound of life. To understand the solitude of this place, we must first understand the scale of its isolation. Zhurong is millions of miles away from the gardens and oceans of Earth. It is a small spark of metal and glass in a desert that covers a whole world. But as the rover begins to scan its surroundings, we realize that this solitude is not empty. It is a landscape filled with character, written in the textures of the ground and the clarity of the light. The sun, now higher in the sky, appears as a small, intense white disk. Because the atmosphere of Mars is so thin, less than 1% of Earth's density, the sunlight doesn't scatter in the same way. The shadows are not soft. They are deep, sharp, and ink black. Every pebble on the surface casts a long, dramatic finger of darkness across the orange sand, making the world look like a high-contrast photograph. Zhurong begins its first true traverse, moving away from the safety of its landing site. Each wheel turns with a slow, deliberate cadence. Crunch. Pause. Crunch. The sound is muffled as if the planet is trying to absorb the noise of the intruder. The soil here is a complex mixture. It is mostly volcanic basalt, ground down over eons into a fine abrasive silt. But mixed within it are salts and minerals that hint at a much more active past. As the rover moves, it leaves behind a trail of neat, monogeometric treads. These tracks are the first new markings this land has seen in millions of years. On Earth, Tracks like these would be washed away by rain or covered by growing grass in a matter of days. Here, they might last for centuries, a permanent record of a Tuesday afternoon spent exploring the void. The solitude of Utopia Planitia is also a solitude of temperature. Even in the height of the Martian day, the air remains bitterly cold. Zhurong feels the environment through its thermal sensors. It is a world of extremes. The rover's toes, the wheels touching the ground, might be resting on soil that is barely freezing, while its head, the camera mast just a few feet higher, is bathed in air that is 40 degrees colder. This stratification creates a strange, shimmering effect in the distance, a Martian mirage born of cold air and dust. The rover moves through this chill with mechanical indifference, but for a human observer, the cold would feel like a physical presence, a reminder that this is a world where heat is a rare and precious commodity. As we watch the rover navigate, we begin to notice the subtle features of the plane. It isn't just a flat waste. There are wrinkle ridges, vast undulating waves in the crust, where the planet literally shrank and buckled as it cooled billions of years ago. There are small impact pits, tiny craters no bigger than a dinner plate, where pebbles from space have rained down over the millennia. Each of these features is a testament to the passage of deep time. In the solitude of Mars, nothing is ever truly lost. It is simply preserved in the cold, with dry air. Zhurong is like an archaeologist walking through a museum where the exhibits haven't been touched in an eternity. The rover pauses. Its sensors have detected a slight change in the ground's resistance. It is entering a patch of polygonal ground. If you were to look down from above, you would see the surface of Mars cracked into giant hexagons and pentagons, like a dried-up lake bed on Earth, but on a much grander scale. These cracks are caused by the seasonal freezing and thawing of ground ice deep below the surface. Even here, in the middle of a desert, the planet is breathing. The ground expands in the warmth of the sun and contracts in the brutal chill of the night, creating a slow-motion dance of geology that takes centuries to complete a single step. Zhurong lingers here, and its cameras capturing the intricate patterns of the cracks. In the silence, you can almost imagine the ice groaning deep beneath the wheels, a hidden world of frozen water waiting for someone to notice its presence. The solitude of the rover is shared by its human creators back on Earth, but in a different way. There is a light delay, the time it takes for a signal to travel between the two planets. When the scientists in the control room send a command to move, it takes minutes, sometimes up to 20 minutes, to reach the rover. By the time they see the rover move on their screens, it has already been sitting still again for a long time. This gap in time creates a strange, ghost-like relationship. Zhurong is always in the past for us, and we are always in the future for it. It operates in a bubble of autonomy, making its own decisions about how to avoid a sharp rock or how to balance its power usage. It is a lonely existence, but it is an existence defined by extreme competence. As the Martian afternoon begins to wane, the sky changes from its midday butterscotch to a deeper, bruised purple. The wind begins to pick up, a low, haunting whistle as it passes through the rover's camera mast and over the edges of its solar panels. This wind is not strong enough to knock the rover over. The air is too thin for that, but it is strong enough to lift the finest grains of dust into the air. A thin orange haze begins to blur the horizon, making the sun look like a pale, ghostly eye. This is the dust cycle of Mars. Every day, the heat of the sun stirs the atmosphere, creating tiny dust devils that dance across the plains like spinning dervishes. Zhurong watches one of these spirals move in the distance, a silent, swirling column of red sand against the indigo sky. It is the only other thing that moves in this world. In this moment of profound isolation, the rover represents the best of us. It is a testament to the idea that we can reach out across the darkness and touch another world, not to conquer it, but to understand it. The solitude of Utopia. Planitia is not a lonely thing. It is a sacred thing. It is the silence of a laboratory, the quiet of a cathedral, a place where the fundamental questions of the universe can be asked without distraction. Where did the water go? Was there ever life here? Are we truly alone in the dark? Zhurong stands still as the shadows of the ridges grow longer, stretching out like dark capes across the sand. Its mission is just beginning. But in these first few days of wandering, it has already become part of the landscape. It is no longer a foreign object. It is a Martian citizen, a golden inhabitant of the northern plains. The tracks it has made are now part of the geology of Utopia Planitia, a new layer in the ancient story of the planet. As the cold begins to deepen and the rover prepares to hunker down for the night, it sends one last panoramic view back to the orbiter. The image shows the vastness of the horizon, the sharp clarity of the rocks, and the absolute unwavering peace of the desert. It is a view that humbles the spirit and quiets the mind. Here there is no chaos. There is only the slow, inevitable turn of the planet in the cold light of the stars. But as the rover's cameras tilt slightly downward, they catch something else. A subtle glimmer in the shadows of a nearby rock, a texture that doesn't quite match the dry dust of the plains. It is a hint that the surface we see is only a mask, a thin veil hiding a much deeper, much more complex history. The silence of the plains is about to be broken, not by sound, but by the invisible pulses of the rover's radar, reaching down into the dark to find what has been hidden for billions of years. The journey is moving from the visible world of dust and shadow into the invisible world of the deep past, where the echoes of an ancient ocean are waiting to be felt. Chapter 3, The Radar's Silent Call. Close your eyes and imagine a light that can see through solid ground. As Zhurong stands perfectly still on the surface of Utopia Planitia, it prepares to engage its most profound sense, the roper, or the Mars rover penetrating radar. In the absolute stillness of the Martian afternoon, the rover begins to send invisible pulses of electromagnetic energy deep into the belly of the planet. These are not sounds that we could hear with our ears, but rather rhythmic heartbeats of light traveling at unimaginable speeds through the dust, the rock, and the ice. Each pulse is a question sent into the dark, a silent call into the depths of a world that has kept its secrets buried for billions of years. Think of the patience required for this kind of vision. On Earth, we are used to the immediate. We look at a forest and see trees. We look at a mountain and see stone. But Zhurong sees the world as a series of echoes. As the pulses of energy dive beneath the red surface, they encounter different materials. Some waves strike solid volcanic basalt and bounce back quickly. Others find softer, more porous layers of sediment and slow down, their reflections returning with a different texture, a different color in the spectrum of the radar. To the rover's computer, the ground is not solid. It is a translucent record of time, a ghost map of everything that has ever happened in this quiet corner of the cosmos. Imagine these waves descending 10 meters, 20 meters, and then 35 meters into the crust. At these depths, the sun's warmth never reaches. It is a place of eternal, absolute darkness. And yet, it is here that the truth of Mars resides. As the radar pulses travel, they are looking for dielectric interfaces, the boundaries where one type of material meets another. When a wave hits a layer of mineral that was once soaked in water, it changes. The reflection becomes sharper, more intense. These are the bright reflections that the scientists back on Earth have been searching for. They are the fingerprints of a wet world, preserved in the deep freeze of the Martian subterranean. As you breathe in and out, let your mind follow one of these pulses. It leaves the rover's antenna, a clean, sharp burst of energy. It passes through the top layer of fine, rusted dust, the regolith that Zhurong's wheels have been treading upon. This top layer is dry, desiccated by eons of exposure to the vacuum of space and the harsh ultraviolet rays of the sun. But as the pulse goes deeper, it enters a region of compacted rocks, boulders that were tumbled and smoothed long ago. The radar sees them as a chaotic jumble, a memory of a time when the ground was not a static desert, but a place of movement and energy. Deeper still, the pulse reaches 30 meters. Here, the radar detects something extraordinary, a series of 76 distinct layers. These are not random. They are organized, stacked one on top of the other, like the pages of a very old, very heavy book. Each layer represents a specific event, a chapter in the hydrological history of Utopia Planitia. To a human eye, the surface is just a flat expanse of red, but to Zhurong's radar, it is a vertical museum. When these 76 layers are made of hydrated minerals, clays and sulfates that could only have formed in the presence of liquid water. Consider the stillness of those layers. They have not been disturbed for hundreds of millions of years. They sit in the dark, holding the chemistry of an ancient ocean. When the radar calls to them, they answer back with a specific resonance. This is the silent conversation between a machine from the future and a landscape from the deep past. The data flows back into Zhurong's memory banks, a stream of numbers that will eventually be translated into a picture of a world we never knew. This process of sounding the ground is slow. Zhurong does not rush its investigations. It stands for hours, sending pulse after pulse, averaging the data to filter out the noise of the cosmos. In the background, and the background radiation of the galaxy hums, a faint hiss from the Big Bang that every electronic device must contend with. But Zhurong is focused. It is looking for the discontinuities, the places where the story changes. By measuring the time it takes for each pulse to return, the rover can calculate the density and composition of the ground to a precision of just a few centimeters. As you drift deeper into relaxation, imagine the verticality of this journey. We often think of space exploration as looking up at the stars, but tonight we are looking down into the Earth. The deeper we go, the further back in time we travel. The top few meters represent the recent history of Mars, the last few 100 million years of dry, dusty silence. But as we pass the 10-meter mark, we are entering the Amazonian epoch, a time when the planet was already cooling, but still capable of sudden, dramatic changes. And when we reach 35 meters, we are touching the Hesperian era, a time of transition when the great oceans were starting to retreat, leaving behind the minerals that Zhurong now detects. The radar's call is a bridge. It connects the dry, frozen present with a vibrant liquid past. It tells us that the dirt beneath the rover's wheels is not just dirt. It is a witness. It saw the rise and fall of tides. It felt the weight of a sea that was hundreds of miles wide. The 76 layers found by Zhurong are like tree rings, recording the cycles of the planet's climate. Some layers are thick, indicating long periods of stability in standing water. Others are thin and jagged, hinting at sudden floods or brief interlopes of warmth. The silence of the radar is its strength. Unlike a drill, it does not break the ground. It does not disturb the ancient sleep of the minerals. It simply observes through the medium of electromagnetism. It is a gentle way of knowing. As the sun begins to move lower in the sky, Zhurong finishes its first deep-sounding session. The data is secure, a treasure haul of information that will take years for humans to fully comprehend. But the most important revelation is already clear. The water did not just vanish in a single moment, it stayed. It retreated into the soil, leaving behind these mineral ghosts to tell us where it had been. Think about the sheer volume of information hidden in those 76 layers. Each one contains clues about the temperature of the water, its acidity, and its salt content. Each one is a snapshot of a different Mars. One layer might tell of a calm, shallow lagoon where minerals settled slowly to the bottom. The next might speak of a sudden surge of mud and ice, a slurry that swept across the plains during a volcanic eruption. The radar sees it all, a silent witness to a billion years of change. As the rover prepares to move again, the radar continues its work in the background, a constant ping into the abyss. It is a rhythmic, meditative process. Send, wait, receive, record. The cycle repeats, a technological mantra that grounds the mission in the reality of the physical world. The plains of Utopia Planitia may look empty, but we now know they are full. They are heavy with the weight of water that is no longer there, yet whose memory is etched into every grain of sand and every layer of stone. Zhurong is not just a traveler, it is a listener. It has heard the silent call of the deep layers, and it has recorded their answer. This discovery shifts our perspective. We are no longer looking at a dead world, but a world with a complex, hidden biography. The radar has opened a door that can never be closed again. It has shown us that to understand the stars, we must sometimes look deep into the shadows beneath our feet. As the rover's internal systems begin to process the day's findings, a new picture of Mars begins to emerge. It is a picture of a world that held on to its secrets with a quiet, icy grip, waiting for a visitor with the right kind of vision to come and ask the right questions. The radar's silent call has been answered, and the echoes are leading us toward a coastline that hasn't seen a wave in an eternity. The data tells a story of a shore that was once vibrant, a place where the air might have been thick enough to breathe and the sky might have held clouds. As Zhurong turns its gaze toward the horizon, it is no longer just seeing a desert. It is seeing the phantom of a great sea, a sea whose history is now mapped out in the 76 layers of the deep ground. The transition from the dry surface to the hydrated depths is a transition of the mind, a realization that we are standing on the edge of something much larger than a mere plane. We are standing on the threshold of an ancient, watery world, and the path forward is marked by the very waves that the radar has just rediscovered in the dark. Chapter 4. The Ghost of an Ocean. Allow your mind to drift deeper into the stillness of the Martian crust, moving beyond the mechanical pulses of the radar and into the quiet reality of what those pulses have uncovered. As Zhurong stands atop the vast northern plains, we are no longer looking at a simple desert of rust and bone-dry stone. Through the eyes of science, the landscape has transformed. Beneath the rover's 6 wheels lies the phantom of a colossal body of water, an ancient silent sea that once dominated the northern hemisphere of Mars. This is the ghost of the Vastitas Borealis, a primordial ocean that once rippled under a younger, warmer sun. Imagine the sheer scale of it, a liquid horizon that stretched for thousands of miles, its waves gently lapping against the very ground where Zhurong now rests in solitary silence. To walk upon Utopia Planitia today is to walk upon a graveyard of tides. When the radar detected those 76 distinct layers of hydrated minerals, it wasn't just finding rocks. It was finding the chemical signatures of a drowned world. Imagine the water as it once was, not the clear, blue Caribbean waters of Earth, but a deep, mineral-rich green or a dark, iron-tinted gray, heavy with the sediments of a cooling planet. The air would have been thick then, filled with the scent of salt and damp earth, a world that breathed with the rhythm of moving water. As you relax into the present moment, let the memory of that ancient water flow through your thoughts. The transition from a world of oceans to a world of dust did not happen in a heartbeat. It was a slow, agonizing withdrawal that lasted for hundreds of millions of years. In the 76 layers identified by Zhurong are the physical remains of this retreat. Each layer is a sedimentary sequence, a term geologists use to describe the slow settling of materials at the bottom of a lake or sea. Imagine a calm period on Mars 3 billion years ago. Fine silts and clays carried by rivers from the southern highlands reached the northern lowlands and slowly began to sink. In the low gravity of Mars, this settling happened with a dreamlike slowness. Particles drifted through the water like microscopic snowflakes, eventually forming a soft, muddy carpet on the floor of Utopia Planitia. Over thousands of years, these particles compacted, trapped by the weight of the water above them. These are the hydrated minerals, the clays that still hold the molecular memory of H2O within their crystalline structures. As we descend deeper into this concept, consider the shoreline that Zhurong is currently investigating. For decades, orbital photographs showed strange features along the edge of the northern plains, long winding ridges and terraces that looked remarkably like the beaches of Earth. But looking from space is like looking at a blurry photograph. Zhurong provides the ground truth. By finding minerals that can only form in standing water, the rover has confirmed that this wasn't just a temporary flood or a localized pond. This was a sustained, deep water environment. The ghost of an ocean is real. It is written in the sulfates and carbonates that now lie frozen beneath the dust. Think about the silence of a sea that has no life to disturb it. On Earth, our oceans are teeming with the sounds of whales, the scuttling of crabs, and the rustle of kelp forests. But the Martian ocean was a place of profound alien stillness. There might have been microbial life, tiny organisms drifting in the currents, but for the most part, it was a world of pure physics and chemistry. The only sounds would have been the wind whipping up whitecaps on the surface and the occasional boom of a distant meteorite striking the water, sending massive tsunamis racing across the planet. Zhurong's radar has captured the chaotic layers left behind by these events. The event beds, where the orderly stacking of sediment was interrupted by the violence of the cosmos. As you breathe in, imagine the weight of that water pressing down on the ground. A sea hundreds of meters deep exerts a massive amount of pressure, forcing water into the pores of the rocks below. Also, this is why the radar reflections are so bright 30 meters down. The water didn't just evaporate into space, much of it was swallowed by the ground itself. It turned into permafrost, a thick layer of ice and mineral sludge that has remained protected from the sun for eons. The ghost is still there, in a way, not as a liquid, but as a frozen monument. Zhurong is sensing the thermal and electrical properties of this buried ice, mapping the boundaries of a lost world that is hidden just out of reach. The colors of this lost world would have been breathtaking. At sunset, the Martian sky, even then, would have turned a soft blue near the sun, casting a cool light over the vast expanse of the green-gray sea. The waves would have been taller than those on Earth because of the lower gravity, moving with a slow, heavy grace. Imagine the sound of a 20-foot wave breaking in slow motion against a basaltic cliff, the spray hanging in the air like a mist of diamonds. This is the world that Zhurong's data is reconstructing for us, one layer at a time. It is a world that existed for 1 billion years, longer than it took for complex life to evolve on Earth. Yet it ended in a long, slow drought that turned the sky red and the seas to stone. As the rover moves across the plains, it is essentially sailing across the floor of this vanished sea. The polygonal ground we discussed earlier, those hexagonal cracks in the soil, are the scars left behind as the last of the water evaporated and the ground began to shrink and freeze. It is a landscape of dehydration, but the radar tells us that the dehydration is only skin deep. Beneath the surface, the minerals are still wet in a chemical sense. They are the guardians of the planet's history, holding on to the evidence of a time when Mars was a brother to the Earth, a blue and white marble in the darkness. Let your mind rest on the idea of deep time. When we talk about the ghost of an ocean, we are talking about a scale of history that makes human civilizations seem like a single heartbeat. The 76 layers represent cycles of climate that lasted tens of thousands of years each. Perhaps the planet's tilt shifted, bringing a few centuries of warmth that melted the ice and refilled the basin, only for the cold to return and turn the sea back into a desert. Zhurong is reading these cycles like a cosmic metronome. Each bright reflection in the radar data is a beat in the song of the planet, when a reminder that change is the only constant in the universe. The solitude of the rover becomes even more poignant when we realize what it is standing over. It is a lonely machine on a lonely plane, yet it is surrounded by the evidence of a once crowded history. The ghost is everywhere. It is in the way the dust clumps together, in the chemical composition of the rocks, and in the very gravity that pulls at the rover's chassis. We are learning that Mars was never meant to be a desert. It was a world that tried to stay wet, a world that fought to keep its oceans even as its atmosphere was slowly stripped away by the solar wind. As we conclude this exploration of the ancient sea, consider the legacy of the water. It shaped the mountains, it carved the valleys, and it left behind the minerals that may one day help human explorers survive on the surface. The water is the soul of Mars's story, and Zhurong is its biographer. The data being collected tonight is more than just numbers, it is a resurrection. We are bringing the ocean back to life in our minds, visualizing the waves and the tides as they once were. And in doing so, we are narrowing the gap between our world and the red one. The rover now turns its sensors toward a new set of anomalies, strange white-tinted crusts on the nearby dunes. These are not ancient. They look fresh, as if they were formed only yesterday. The story of water on Mars is not just a tale of the distant past, it is a tale of the recent present. The ghost of the ocean may be long gone, but the ghost of the water still haunts the dunes in the form of frost and salt. As Zhurong inches forward to investigate these salted dunes, We begin to see that the planet's hydrological heart is still beating, however faintly, in the cold Martian night. The transition from the deep, ancient layers of the ocean floor to the delicate, modern crusts of the surface is a reminder that the history of Mars is a living thing. The rover is moving from the macro to the micro, from the scale of oceans to the scale of a single snowflake. As the wind begins to hiss against the rover's mass, carrying the faint scent of mineral salts, we prepare to uncover how the planet still manages to find moisture in a world of ice, a discovery that will lead us into the mystery of the great Martian floods and the strange, frozen weather of the modern era. Chapter 5. The Great Martian Floods. As we move past the haunting silence of the ocean's ghost, let your consciousness drift toward a time of sudden, monumental transformation. Deep beneath the rusted surface where Zhurong now stands, the radar has whispered a secret of violence and majesty that contradicts the stillness of the modern desert. We are entering a chapter of Martian history that feels less like a slow withdrawal and more like a thunderous reawakening. Imagine the planet not as it is now, frozen and hushed, but as it was roughly 1.6 billion years ago. This was the era of the Great Floods, a time when the drying planet found one last, desperate surge of liquid energy. Take a slow, deep breath, and as you exhale, visualize the Martian landscape during the late Hesperian period. The great oceans had already begun to recede, leaving behind the layered minerals we explored earlier. The planet was becoming colder, its atmosphere thinning, its heart beginning to chill. But beneath the surface, immense reservoirs of water remained trapped, held in check by a thick, planetary crust of permafrost. Then something shifted. Perhaps it was the slow, rhythmic crawl of internal heat from the mantle, or perhaps a massive volcanic upheaval at the Tharsis Rise. The ice began to melt from below. Pressure built, a silent, mounting force of liquid water seeking a way out of its stony prison. When the breakthrough finally happened, it was not a trickle, but a cataclysm. Imagine standing on the edge of the Utopia Basin as the ground itself began to heave and buckle. In an instant, the permafrost shattered. What on in a wall of water, hundreds of feet high, erupted from the subsurface. This was not the gentle water of an earthly river. This was a slurry of ice, mud, and ancient boulders, a dark, churning tide that raced across the northern plains with the power of 1,000 storms. In the low gravity of Mars, these floods moved with a terrifying, dreamlike fluidity, carving out massive outflow channels that we can still see today from orbit. The radar pulses from Zhurong have caught the chaotic echoes of these events, showing us layers where the orderly settling of the ocean was replaced by a jumbled, violent mess of debris. Allow your mind to sink into the scale of this power. 1.6 billion years ago, a time when Earth was just beginning to see the rise of complex cells, Mars was experiencing its final, grand hydrological performance. These floods were so vast they could have filled the Mediterranean Sea in a matter of weeks. As you drift deeper into relaxation, imagine the sound of such an event in the thin Martian air. It would have been a low-frequency roar, a vibration that you would feel in your bones long before you heard it with your ears. The water would have been thick with the iron-rich soil of the highlands, a deep, bruised crimson color, foaming with white ice as it crashed into the depressions of Utopia Planitia. This discovery by the Zhurong rover is profound because it challenges everything we thought we knew about the Martian timeline. For years, the scientific consensus was that Mars had become a total desert nearly 3 billion years ago. We thought the story of water had ended in the distant past, but the radar tells a different story. It tells us that Mars was wet much later than we imagined. It tells us that even as the planet was dying, it still had the capacity for renewal. These floods were like a late summer storm in a landscape that was already turning to autumn. They refreshed the lowlands, depositing new layers of sediment and creating temporary lakes that might have persisted for hundreds of thousands of years before finally freezing solid once again. Think about the sediment that settled after the roar of the flood subsided. As the water slowed down, the heaviest boulders dropped first, followed by gravel, then sand, and finally the finest silts. Zhurong is currently parked on top of this very debris. Beneath its wheels is the fallout of a catastrophe. When the radar sends its pulses down, it sees the chaotic interface where the floodwaters met the ancient ocean floor. It is a boundary between two different worlds, the world of the steady, ancient sea and the world of the sudden, violent surge. This tells us that Mars's transition into a desert was not a straight line, but a series of fits and starts, a long drawn-out struggle against the cold. As you breathe, imagine the stillness that followed these floods. After the water settled and the surface began to freeze, the landscape would have looked like a jagged, ice-choked wasteland. Over thousands of years, the wind would begin its work again, grinding down the ice, covering it with dust, and hiding the evidence of the flood beneath a blanket of red sand. But the water didn't disappear. It simply changed form. It retreated back into the ground, not turning into the permafrost layers that Zhurong now senses. The memory of the flood is still there, locked in the electrical conductivity of the subsurface minerals. The great Martian floods represent a moment of cosmic irony. At the very time the planet was losing its ability to hold an atmosphere, its internal heat was creating the most spectacular displays of liquid water in its history. It was a planet at war with itself, the cold sky fighting the warm core. As you listen to the quiet hum of the narration, let yourself reflect on this duality. We often think of planets as static things, but they are living systems of energy and transformation. Mars, in its late Hesperian stage, was a world of punctuated equilibrium, where millions of years of silence were broken by days of unimaginable noise and movement. The implications for life are staggering. If liquid water was surging across the surface only 1.6 billion years ago, it means that any potential Martian organisms had a much longer window to survive and adapt. These floods could have acted as bridges, transporting life from deep, warm underground aquifers to the surface, where it could flourish in temporary lakes before the cold returned. Each flood was a chance for the planet to breathe, to stir the chemical pot, and to move nutrients from the highlands to the basins. Zhurong is not just mapping rocks, it is mapping the life support system of a fading world. Visualize the layers once more. 76 layers. Some of those are the quiet sediment of the ocean. Others are the thick, gravelly beds of the floods. Between them are thinner layers of volcanic ash and wind-blown dust. Together they form a rhythmic history, a planetary song of water and fire. The radar is our needle, reading the grooves of this stone record. And the song it plays is one of resilience. It tells us that water is stubborn, it clings to the rocks, it hides in the shadows, and it waits for the right moment to flow again. As the rover moves across a particularly rocky patch of ground, it is likely navigating the remains of one of these ancient flood channels. The rocks here are imbricated, meaning they are stacked like shingles on a roof, all pointing in the same direction, the direction the water was flowing 1.5 billion years ago. Zhurong pauses to examine a larger boulder, its cameras tracing the smooth, rounded edges that could only have been shaped by the relentless tumbling of a high-energy flood. In the silence of the modern afternoon, it is hard to reconcile this piece with the violence of the past, but the evidence is undeniable. The ground beneath the rover is a monument to the power of the flood. As the sun begins to dip lower, casting long, dramatic shadows across the scarred earth, we begin to see the landscape for what it truly is, a masterpiece of erosion and deposition. The great floods were the final architects of Utopia Planitia, smoothing the rough edges of the impact basin and filling the hollows with the fertile silt of the highlands. This silt, rich in magnesium and iron, would have been the perfect cradle for any late-era Martian life, a mineral-rich soup that sat under a thickening shell of ice. We are left with a sense of wonder at the persistence of the planet's watery heart. Even as the atmosphere bled away and the oceans turned to salt, the floods came. They were a testament to the fact that Mars was not ready to give up. And as we leave the roar of the ancient floods behind, drifting back into the calm of the present day, we realize that the story is still not over. The water that surged 1.6 billion years ago is still there, just beneath the dust, waiting in the form of ice and hydrated salts. The transition from these epic planetary-scale events to the quiet modern reality of the Martian surface is a journey from the roar to the whisper. As the wind whistles softly through Zhurong's instruments, we move from the era of the great floods to a much more recent, much more subtle mystery. The rover is now approaching a series of the dunes, where it has spotted a strange pale crust. It is a discovery that will bring the timeline even closer to our own, showing us that the planet's struggle to stay wet didn't end a billion years ago. It continued until very recently, and in the Defying the Desert age, we will discover that the desert is not as dry as it seems. The echoes of the floods have faded, but the frost is just beginning to speak. Hibernation Chapter 6. Defying the Desert Age. As the echoes of the great floods begin to settle in your mind, imagine the planet Mars entering a period of profound and quiet resistance. We have often been taught that the red planet is a place of static decay, a world that surrendered its vitality billions of years ago. But as Zhurong moves across the surface of Utopia Planitia, its sensors are telling a different story. A story of a world that refused to turn into a total wasteland. This is the era of defiance, a time when Mars, despite losing its atmosphere and its warmth, managed to keep the spark of its hydrological cycle flickering in the dark. Take a long, slow breath and imagine the transition from the roaring floods to this new, more subtle reality. The great surges of water had ceased, and the massive outflow channels began to fill with the fine, rust-colored dust of the highlands. To a distant observer, Mars would have appeared to be finally sleeping, a desert of frozen iron. But beneath the surface, and in the rhythmic tilt of the planet's axis, a secret mechanism was at work. The desert age was not a monolithic block of dryness. It was a complex tapestry of cycles, where moisture moved like a ghost from the poles to the equator and back again. Zhurong's discovery of hydrated minerals only 16 meters beneath its wheels is the physical proof of this defiance. These minerals didn't form billions of years ago during the era of oceans. They formed much later, during a time when we thought the planet was already bone dry. Imagine the chemistry of this resilience. Even when the surface was a freezing vacuum, thin films of liquid water, brines so salty they could resist freezing even at 80 degrees below zero, were still moving through the soil. This wasn't an ocean, but it was a hidden dampness, a microscopic wetness that kept the geology of the planet alive. Visualize the planet as it tilts on its axis over hundreds of thousands of years. On Earth, our tilt is stabilized by our large moon, keeping our seasons relatively predictable. But Mars is a wanderer. Without a large moon to steady it, the red planet wobbles. Every few 100,000 years, the tilt of Mars increases significantly, pointing its icy poles more directly at the sun. During these high obliquity periods, the polar caps don't just melt, they sublimate, turning directly into gas that enters the thin atmosphere. This moisture then travels toward the equator, where it descends upon the plains of Utopia Planitia, not as rain, but as a heavy cosmic frost. Imagine standing on the plains during one of these eras. The indigo sky would be filled with thin, wispy clouds of water ice, shimmering with an iridescent glow in the morning light. As the sun sets, the temperature drops so low that the very air begins to crystallize. A layer of frost, perhaps a few centimeters thick, settles over the red dunes. It is a quiet, ethereal transformation. The desert turns white for a season, a pale reflection of the ancient oceans. When the sun rises again, this frost doesn't all vanish. Some of it melts into the salty soil, creating those thin films of brine that Zhurong has detected. This is how the planet defied the desert, by breathing moisture from its poles into its heart, over and over again, journey through the long reaches of cosmic time. The defiance is also written in the salts. When Zhurong analyzes the soil, it finds high concentrations of perchlorates and sulfates. On Earth, we might see these as harsh chemicals, but on Mars, they are the guardians of water. These salts act like antifreeze. They lower the freezing point of water, allowing it to stay liquid in conditions that should be impossible. Imagine these brines as they move through the pores of the Martian regolith. They are slow, sluggish, and incredibly persistent. They carve out tiny channels between the grains of sand, reacting with the minerals to create the hydrated layers that the radar now sees. The planet was not dry. It was simply salting its water to keep it from being lost to the void. As you drift deeper into relaxation, Anon, think about the silence of this process. It is a world of whispers rather than roars. Unlike the great floods which reshaped the planet in a matter of days, this defiant age reshaped the planet over millions of years, one molecule of brine at a time. It is a testament to the idea that life, or the potential for it, doesn't always need a spectacular environment. Sometimes all it needs is a persistent, salty dampness in the dark. Zhurong is the first witness to this hidden history, its sensors mapping the exact depth where the frost of the past became the minerals of the present. The rover pauses here near a small ridge to take a chemical reading. The data shows a high dielectric constant in the shallow subsurface. This is the scientific way of saying that the ground is still holding on to something. It is not just dead stone. It is a complex matrix of chemistry that is still reacting to the environment. The desert age was a time of hidden complexity. While the surface was being blasted by radiation and scoured by dust storms, the subsurface was a sanctuary. It was a place where the memory of the ocean was kept alive through the clever use of salts and planetary tilts. Consider the patience of the planet. Mars has been waiting for nearly 2 billion years in this state of semi-dormancy. It has watched the stars shift. It has seen the birth and death of volcanic chains, and it has felt the impact of countless asteroids. Through all of it, it maintained these tiny pockets of hydration. Zhurong is walking over a library of resilience. Every meter it travels is another page in a book that tells us we were wrong to dismiss Mars as a dead world. It is a world that has mastered the art of survival in the extreme. A world that knows how to hold on to its soul even when the sun tries to strip it away. The colors of this era would have been subtle and beautiful. Imagine the red dust of the plains mixed with the pale white of the sulfate salts, creating a landscape of pastel pinks and soft creams under the cold Martian light. The wind would still blow, but it would carry with it the faint, sharp scent of chlorine and sulfur, the smell of a planet's laboratory. This is the environment that defined the Middle Age of Mars, a time of transition where the grand scales of the past were condensed into the microscopic scales of the soil. As you breathe in the cool, imaginary air of this Martian evening, let the weight of your body sink further into your bed. Now, much like the salts of Mars sink into the dust, there is a profound peace in the idea of this quiet defiance. It tells us that even in the most desolate places, there is a rhythm and a reason. The desert age was not a failure of the planet to stay wet. It was a masterpiece of adaptation. Mars found a way to recycle its water, to hide it from the sun, and to use the very tilt of its body to survive. Zhurong's presence here is a bridge between our understanding and this alien reality. By measuring the thickness of these hydrated layers, the rover is allowing us to calculate exactly how much water was moving through the system during these cycles. It turns out it was more than we ever suspected. The ghost of the ocean had children, smaller, saltier versions of itself that lived in the soil for eons after the waves had vanished. These soil oceans are what Zhurong is currently mapping, proving that the Red Planet story is one of long, slow continuity rather than abrupt endings. The rover's tracks in the dust are a temporary addition to this ancient landscape, but the knowledge it gathers is permanent. It is uncovering a Mars that is dynamic, a Mars that is still capable of surprise. As we look at the dunes ahead, we see the results of this defiance. The dunes are not just piles of sand. They are structures held together by the very salts and moisture we have been discussing. They have a crust, a hardened skin that protects them from the wind, created by the evaporation of those ancient brines. As the sun begins to set on Zhurong's position, the temperature starts its rapid plunge. The rover's heaters kick in, enter a soft mechanical sigh in the deepening purple twilight. But out there, in the dark, the process of defiance continues. The moisture in the atmosphere is already beginning to feel the pull of the cold, preparing to descend once again as microscopic crystals of frost. The cycle continues, just as it has for millions of years, regardless of whether there is a rover there to see it. We are beginning to realize that the desert age was actually a period of intense, slow-motion activity. It was the time when Mars became the planet we recognize today, a world of red dust and hidden ice. But the discovery of how recently this water was active leads us to an even more startling realization. The defiance of the planet didn't stop in the distant past. It reached all the way into the modern era, into the time when the first humans were beginning to look at the stars with wonder. As Zhurong moves toward the next formation, the texture of the ground changes once again. We are leaving the deep, mineral-rich layers of the Middle Age and approaching the delicate, fragile surface of the now. Here, the story of water becomes even more intimate, focusing on the tiny scales of Zhurong Moi, the frost, and the way it interacts with the dunes under the light of the Martian moons. The transition from the desert age to the physics of Martian snow is a shift from the history of the planet to its current living breath. The defiance of the past has become the weather of the present, and the rover is ready to catch the very next snowflake that falls in the red silence. Chapter 7: The Physics of Martian Snow. As the long-term defiance of the planet settles into a quiet background of geological memory, let your focus narrow even further. We are moving away from the grand scales of millions of years and billions of gallons of water, and stepping into the delicate, immediate world of the Martian night. Imagine the air around the Zhurong rover as the sun disappears completely below the horizon. The sky, which was once a bruised purple, now deepens into a black so profound it feels like a physical weight. The temperature begins a sharp vertical descent, dropping second by second until the very molecules of the atmosphere begin to react. This is the moment when the physics of the red planet reveals its most fragile beauty, the birth of Martian snow. To understand this snow, we must first set aside everything we know about winter on Earth. Our snow is born of thick, moist clouds and heavy, humid air. But on Mars, the air is a ghost, thin, dry, and composed almost entirely of carbon dioxide. Yet within this thin veil, there are traces of water vapor, tiny travelers that have survived the trek from the icy poles. As the cold reaches its peak, these water molecules begin to find one another. They don't fall as the heavy, wet flakes of a terrestrial blizzard. Instead, they crystallize into something far more ethereal. Imagine microscopic diamonds, smaller than a grain of dust, forming in the dark. These are the water ice crystals of Mars, so light that they don't so much fall as they drift, dancing on the faint thermal currents of the cooling plains. Honey, let your breathing synchronize with the movement of these crystals. Inhale slowly. Imagine a single crystal of ice, a perfect geometric lattice, shimmering under the light of Phobos and Deimos. Exhale slowly. Watch it drift downward, a slow-motion descent through the indigo void. On Mars, the low gravity and thin air mean that a snowflake can take hours to reach the ground. It is a world of suspended animation. In the silence of Utopia Planitia, millions of these tiny messengers are descending upon the dunes, a silent, white mist that begins to coat the rust-colored sand. But Martian snow has a secondary, even stranger form. Because the temperature drops so low, down to minus 120 degrees Celsius, the carbon dioxide in the air itself begins to freeze. This is dry ice snow. Imagine a snowfall where the very air you breathe turns into solid flakes. These CO2 crystals are heavier and more crystalline than the water ice frost. They fall like tiny frozen needles, clinking softly against the rover's camera lens, though the sound is too faint for any human ear to detect. This dual nature of Martian winter, the delicate water ice and the sharp dry ice, creates a landscape of surreal textures. The dunes are not just covered in frost, they are transformed into a crystalline kingdom. Zhurong has watched this happen. Its sensors have recorded the albedo change, the way the ground becomes more reflective as the frost takes hold. Imagine the rover sitting in the dark, its gold foil insulation reflecting the faint white glow of the frozen ground. The dunes, which by day are a warm, inviting orange, can now look like ghosts of themselves draped in a pale, shimmering shroud. This snow is not just a weather event, it is a bridge. It is the way the planet moves water from the atmosphere back into the soil, keeping the cycle of hydration alive in the modern era. Think about the silence of a Martian snowfall. There is no sound of wind through trees, no muffled quiet of a buried city. There is only the absolute, unwavering stillness of the vacuum-like air. If you were standing there, you would feel a cold so intense it would seem to stop time itself. But in that cold, there is a perfect order. The crystals of ice don't clump together into messy slush. They remain individual, pristine, and sharp. They settle into the cracks of the rocks and the ripples of the sand, highlighting the intricate geometry of the landscape. The polygonal ground, those giant hexagons we discussed earlier, are now traced in brilliant white, making the plains look like a vast, celestial mosaic. As you drift deeper into sleep, visualize the interaction between the snow and the dust. Martian dust is rich in iron, giving it a magnetic quality. The ice crystals often form around a tiny grain of this dust, using it as a nucleus. Each snowflake is carrying a piece of the planet's heart within it. When they reach the surface, they don't just sit there. Even in the middle of the night, a process called sublimation is occurring. Some of the ice turns back into gas, while some of it, fueled by the tiny amount of heat trapped in the dark sand, begins to interact with the salts. This is the magic of Martian physics. The snow meets the salt, and for a brief microscopic moment, a liquid is born. Not a flowing river, but a microbrine, a thin film of water that exists between the grain of sand and the crystal of ice. This film is what creates the crusts that Zhurong has found on the dunes. The snow falls, it melts slightly into the salt, and then it freezes solid, acting like a cosmic glue. This is why the dunes of Mars don't just blow away in the wind. They are armored by the snow, held together by a fragile, frozen skeleton. Consider the rhythm of this process. It happens every night in the winter, and every morning as the sun rises, the snow vanishes, turning back into a ghostly mist that rises into the sky. It is a daily resurrection. The planet breathes out the frost at night and breathes it back in during the day. Zhurong is the first explorer to sit in the middle of this breath, in measuring the humidity and the pressure with a precision that allows us to see the heartbeat of the weather. The snow also tells us about the Milankovitch cycles of Mars, the long-term changes in the planet's tilt. We are currently in a dry cycle where snow is rare and thin. But we know from the layers beneath the rover that there were times when the snow fell for centuries without stopping, building up into vast glaciers that covered the northern plains. The physics of Martian snow is not just about the flakes falling tonight, it is about the power of the small to become the great. 1 billion snowflakes became a glacier. 1 billion years of frost became the hydrated minerals of the deep crust. As you imagine the soft white crystals settling onto the rover's solar panels, let your own thoughts become light and drifting. And there is no urgency in the Martian winter. The planet is content to wait. The rover is content to wait. The snow falls with a grace that is indifferent to time, a slow-motion ballet performed for an audience of stars. The indigo sky above is filled with the light of distant galaxies, each one a reminder of the vastness of the stage upon which this tiny frozen drama is playing out. The snow we see tonight is a message from the poles. It is a reminder that even in the most desolate parts of the desert, the planet is connected. The water that was once an ocean in Utopia Planitia is now a snowflake on a dune. It is the same atoms, the same history, just in a different form. Mars is a master of transformation. It knows how to be a sea, and it knows how to be a crystal. It knows how to be a flood, and it knows how to be a whisper. As the pre-dawn light begins to touch the highest peaks of the distant craters, the snowfall begins to taper off. The air becomes slightly warmer, and the water ice crystals begin to shimmer with an internal light. The white shroud on the dunes starts to thin, the molecules readying themselves for their return to the sky. But the ground has changed. It has taken a little bit of that moisture, a little bit of that coolness, and tucked it away into the salts. The physics of snow has completed its nightly work, and the cycles of the red planet are ready to take over. The transition from the individual snowflake to the global cycle is a shift in perspective. We have seen how the cold creates beauty in the dark, but now we must understand why the cold comes and goes in the first place. The snow is the symptom, and the tilt of the planet is the cause. As Zhurong's cameras watch the first hint of morning light turn the white frost into a soft, glowing gold, we prepare to look upward and outward. We are moving from the microphysics of the ice to the macrophysics of the solar system, where the slow, heavy wobble of Mars determines the fate of its water. The snowflake is melting, but the cycle that created it is as eternal as the stars, and the rover is ready to track its rhythm into the deeper history of the Martian tilt. Chapter 8. Cycles of the Red Planet. As the morning sun begins to sublime the nightly frost back into the thin Martian air, let your mind tilt upward, away from the microscopic crystals and toward the grand mechanics of the solar system. We are entering a chapter of time that is measured not in hours or days, but in hundreds of thousands of years. This is the story of the Milankovitch cycles of Mars, the heavy, rhythmic wobble of a world that determines when the oceans sleep and when the snow awakens. As you settle deeper into your rest, imagine the planet itself as a giant, spinning top, drifting through the velvet dark of space, performing a slow and ancient dance that changes the very face of its landscape. To understand these cycles, we must first look at the obliquity of Mars, the angle at which the planet leans as it orbits the sun. On Earth, we are stabilized by our massive moon. It acts like a steadying hand, keeping our tilt relatively constant at 23 degrees. This stability gives us our predictable seasons and our stable climate. But Mars is a lonely wanderer. Its two moons, Phobos and Deimos, are mere pebbles in the cosmic ocean, too small to exert any calming influence. Consequently, Mars wobbles violently over the eons. Its tilt can shift from nearly upright to a dramatic 45 degrees. Imagine the planet slowly bowing toward the sun, exposing its icy poles to the direct heat of the solar rays. This is the heartbeat of the red planet, a cycle of leaning and straightening that dictates the destiny of every drop of water it possesses. Take a slow, deep breath and visualize the planet during a period of high obliquity. As Mars tilts forward, the polar ice caps, which have been frozen for thousands of years, are suddenly thrust into the sunlight. The carbon dioxide and water ice do not melt into liquid. Instead, they sublime, turning directly into gas. Imagine vast plumes of white vapor rising from the poles, filling the thin atmosphere until it becomes thick with moisture. This moisture doesn't stay at the poles. It is carried by global winds toward the equator, descending upon the plains of Utopia Planitia. During these eras, the desert we see through Zhurong's eyes today was not red. It was a world of white, buried under meters of snow that lasted for centuries. This is why Zhurong's discovery of hydrated minerals at shallow depths is so vital. It proves that these cycles are not just theoretical, when they are a functioning weather system that has operated as recently as 400,000 years ago. Think about that time frame. While early humans on Earth were beginning to master fire, Mars was undergoing a transformation. The cycles of the red planet were bringing moisture to the very ground where the rover now stands. The snow that fell during those periods didn't just vanish. It interacted with the salty soil, creating the layers of mineral crust that Zhurong has mapped. You are resting on a world that is not dead, but merely between breaths. We are currently in a low obliquity phase, a quiet, dry summer that has lasted for thousands of years, but the tilt will inevitably shift again. As you drift further into relaxation, imagine the sheer slowness of this movement. If you were standing on Mars, you would never feel the tilt. Oh, it is a transition that takes 50,000 years to move a single degree. It is the ultimate slow cosmic narration, a story written in the stars and executed in the ice. This wobble is caused by the gravitational tug-of-war between Mars and its larger neighbors, Jupiter and Saturn. The giant planets pull at the red planet, nudging its orbit, stretching it from a circle into an ellipse, and then back again. Each tug changes the amount of sunlight that reaches the surface. Each nudge determines whether the water stays hidden in the ground or rises into the sky. Zhurong is our witness to this celestial clockwork. By measuring the thickness and composition of the soil layers, the rover acts as a chronometer. It shows us how long each wet cycle lasted. Some layers are thin, suggesting a brief tilt that barely had time to melt the frost. The others are thick and rich in salts, hinting at a great summer that lasted for an epoch. As you exhale, imagine the weight of these cycles pressing down on the history of the planet. There is a profound peace in knowing that the desert is temporary. The red planet has a rhythm, a promise of return. The water is patient, it knows the tilt will come back. It knows the sun will eventually touch the poles again. Consider the precession of the orbit, the way the planet's axis rotates like a compass needle. This, combined with the eccentricity of the orbit, creates a complex symphony of climate. There are times when the northern hemisphere has long, cold winters and short, hot summers, and other times when the pattern is reversed. Utopia Planitia is a record keeper of these variations. Every polygonal crack in the ground, every ripple in the dunes, is a response to a specific moment in the Milankovitch cycle. Zhurong is not just exploring a place, it is exploring a schedule. It is learning when the planet breathes in and when it breathes out. Think about the atmosphere during the peak of a high-tilt cycle. The air would be dense enough to support thick, low-hanging clouds. At night, the sky wouldn't be the empty black we see now, but a shimmering vault of silver blue, filled with the glow of suspended ice crystals. The wind would carry a different weight, a dampness that would feel familiar to a traveler from Earth. This is the hidden Mars, the one that exists in the high obliquity future. Zhurong's data allows us to simulate this world, to hear the phantom sound of its winds and feel the chill of its ancient snows. As your body feels heavier and more supported by your bed, let your mind rest on the stability of this cycle. In a universe that often feels chaotic, the orbital mechanics of the solar system offer a beautiful mathematical certainty. The planets move with a precision that exceeds any human clock. Mars will wobble, the ice will sublimate, the snow will fall. It is an eternal loop, a cosmic rerun that has played out millions of times since the birth of the sun. Zhurong is simply the first creature, organic or mechanical, to sit still long enough to understand the tempo of the music. The salts that Zhurong finds on the surface are the residue of these cycles. When the tilt changes and the moisture retreats back to the poles, the water leaves behind the minerals it was carrying. These salts are like the salt lines left on a beach after the tide goes out. They tell us where the moisture was, how long it stayed, and how intense the Martian summer became. By analyzing these salts, Zhurong is reconstructing the ebb and flow of a sea that is made of frost and dust instead of liquid waves. It is a slow, methodical reconstruction of a climate that operates on a scale humans can barely comprehend. Imagine the planet's axis slowly beginning its next long journey. It is a movement so infinitesimal that it would be lost in the noise of a single day. But over the next 100 centuries, it will change everything. The poles will begin to warm, the shadows in the deep craters will shift, and the moisture currently locked in the northern cap will begin to feel the first faint pull of the equator. Zhurong will be long gone by then, a gold and silver relic buried under a new layer of white. But the story it started will continue. The rover is a scout for a future it will never see, a future where the desert of Utopia Planitia is once again a garden of ice. This perspective shifts the way we see the solitude of the rover. It is not alone in a dead world. It is an observer in a world that is resting. The silence of the plains is the silence of a theater before the play begins. The cycles of the red planet are the stagehands, slowly moving the scenery, preparing for the next act of the Martian story. Zhurong has given us the script, showing us how the water moves and where it hides. As the light of the morning sun warms the rover's chassis, we begin to look closer at the soil itself. We have seen the grand cycles and the falling snow, but what about the life that might be waiting for the next great summer? The moisture from the tilt and the chemistry of the salts create a unique opportunity. Beneath the surface, in the damp, dark places where the radar pulses found their brightest echoes, a different kind of resilience might be at work. The transition from the orbital cycles to the chemistry of resilience is a move from the cosmic scale to the biological one. We are going to look for the sleeping microbes, the entities that have learned to live according to the rhythm of the Martian wobble, waiting for the tilt to bring them back to life. The cycle is turning, the sun is rising, and the rover is ready to peer into the microscopic havens of the deep sand. Chapter 9. The Chemistry of Resilience. As the grand orbital cycles of the planet continue their slow and silent rotation in the background of your mind, let your focus descend once more. We are moving from the vastness of the solar system down into the microscopic world between the grains of Martian sand. Imagine the Zhurong rover standing still in the deepening twilight of Utopia Planitia. Beneath its metal chassis, a hidden world of chemical struggle and survival is unfolding. This is the story of the salts, the perchlorates and sulfates that act as the ultimate guardians of Martian water. In the absolute cold of the desert, where any normal droplet of water would freeze into a solid crystal in an instant, these minerals perform a kind of cosmic alchemy. They allow liquid to exist where it has no right to be. Take a long, slow breath, and as you exhale, imagine the texture of the soil beneath the rover's wheels. It is not just dead dust. It is a complex reactive matrix of iron, magnesium, and salt. When Zhurong's laser-induced breakdown spectrometer fires its tiny beam of light, it reveals a high concentration of perchlorates. On Earth, these are rare and powerful chemicals, often used in rocket fuel. But here on Mars, they serve a more peaceful, meditative purpose. They are hygroscopic, meaning they have a profound hunger for moisture. Even in an environment that is 1,000 times drier than the Sahara Desert, these salts can reach out into the thin air and pull in individual molecules of water vapor. They are the planet's way of breathing in the dampness of the night. Visualize the process of deliquescence. It is a word that sounds like a slow, melting dream. As the temperature drops at night and the relative humidity rises, the salt crystals on the surface begin to absorb enough water from the atmosphere that they actually dissolve themselves. A tiny microscopic bead of liquid is formed. It is not pure water. It is a brine, a liquid so salty that it stays fluid even when the temperature reaches 80 degrees below zero. Imagine these billions of tiny hidden droplets scattered through the top few centimeters of the Martian soil. They are too small for the eye to see, but they represent a massive, invisible reservoir of resilience. They are the chemistry of life waiting for its moment. As you drift deeper into relaxation, let the idea of this salty resilience soothe your thoughts. We often think of salt as something that preserves the dead, but on Mars, salt is what preserves the possibility of the living. These brines are like a liquid safety net. They create thin films of water that wrap around the grains of sand, providing a medium where chemical reactions can still occur, even in the middle of a frozen wasteland. Zhurong has detected the electrical signature of these films. By measuring how the ground conducts electricity, the rover can feel the presence of this liquid. It is a discovery that changes the red planet from a world of stone into a world of hidden fluidity. Think about the silence of these chemical reactions. While the wind whistles outside, inside the soil, ions are moving. Molecules are breaking apart and reforming. The perchlorates are interacting with the iron, creating a slow-motion metabolism that has lasted for eons. This is the chemistry that bridges the gap between the great floods of the past and the sleeping microbes of the future. The water didn't just leave, it went into hiding. It became part of the salt, part of the minerals, waiting for the right temperature and the right pressure to return to a more active state. Imagine the microscopic landscape within a single gram of Martian soil. To a tiny organism, this would be a world of jagged crystalline mountains and vast dark caves of basalt. And flowing through those caves are the brines, thick, heavy, and rich in nutrients. This is the interstitial world, the world in the gaps. Zhurong is the first explorer to map the chemistry of these gaps with such precision. It shows us that the surface we see is just a mask. The real story of Mars is happening in the dark, in the microscopic spaces where the salts are holding on to the last remnants of the ancient sea. Consider the patience of these chemicals. They do not age the way biological things do. A perchlorate crystal can wait for 1 billion years for a single molecule of water to arrive. It does not grow tired. It does not lose its purpose. It simply exists in a state of permanent readiness. This is the kind of resilience the universe demands from a planet that has lost its atmosphere. Mars has had to become a chemist to survive. It has had to turn its very soil into a laboratory of preservation. As you listen to the rhythmic pulse of this narration, let your own body find that same sense of quiet readiness, a state where you are perfectly still, yet filled with the potential for life. The colors of this chemical world are subtle and strange. When the brines interact with the light of the rising sun, they create a shimmering, wet look on the sand that vanishes within seconds as the water evaporates back into the sky. Zhurong's cameras have caught these fleeting glimmers, the Martian dewdrops of a salty world. They are a pale iridescent green or a soft metallic blue, reflecting the complex minerals dissolved within them. They are the only liquid we have ever seen on the surface of another world, and they exist only because of the salt's defiance. The chemistry of resilience is also a story of protection. The same salts that keep the water liquid also act as a shield. They absorb the harsh ultraviolet radiation from the sun, protecting the deeper layers of the soil from being sterilized. Beneath the crust that Zhurong has found, the environment is remarkably stable, and the temperature doesn't fluctuate as wildly, and the chemistry remains consistent. It is a sanctuary. Zhurong has peered into this sanctuary with its radar and its spectrometers, finding that the deeper we go, the more habitable the planet becomes. The surface is a desert, but the subsurface is a refuge. Let your mind rest on the idea of homeostasis, the ability of a system to maintain its internal balance. Mars has developed a planetary homeostasis through its soil chemistry. It uses the salts to regulate its water, the dust to regulate its temperature, and the tilt of its axis to regulate its energy. It is a beautiful, self-sustaining machine. Even though it looks broken from the outside, it is functioning with a clockwork precision. Zhurong is not just a visitor, it is a technician, one reading the gauges of this ancient machine and telling us that it is still running. The resilience of Mars is a lesson for us all. It tells us that even when the environment becomes hostile beyond imagination, there are ways to adapt. There are ways to hold on to the essentials. For Mars, the essential is water. For us, it might be peace or connection. By studying the chemistry of the red planet, we are learning about the fundamental toughness of the universe. Life doesn't just need a perfect planet, it needs a planet that knows how to fight for its resources. As the rover prepares for its next set of measurements, the wind begins to die down, leaving the plains of Utopia Planitia in a state of absolute crystalline clarity. The stars above are reflected in the tiny salt-crusted rocks, making it hard to tell where the earth ends and the heavens begin. Zhurong stands at the center of this mirrored world, its sensors drinking in the chemical secrets of the sand. It has found the brines, it has mapped the salts, and it has proven that the desert is not a dead end. It is a beginning. The data gathered tonight will eventually be used to help humans find water on Mars. We will look for the highest concentrations of these salts, knowing that they are the maps to the hidden moisture. But for now, the chemistry remains a quiet, alien mystery, a slow-motion dance of ions in the dark. The resilience of the planet has been documented, and the path is clear. We have seen the macro cycles and the microchemistry. Now we must ask the final question. If the water is there, and the protection is there, and the chemistry is there, when is anyone home? The transition from the salt and the brine to the potential for biology is the most exciting step of all. We are moving from the how of Martian survival to the who. As Zhurong's internal processors hum with the weight of the day's chemical findings, we prepare to enter the deepest, most silent part of the night. We are going to look for the long hibernation, the possibility that the very life forms that once swam in the ancient oceans are still here, tucked away in the salty dark, waiting for the cycle to turn. The chemistry has prepared the way. The resilience has kept the door open. Now we follow the rover into the mystery of the sleeping microbes, where the history of Mars may still be alive and breathing in the red silence. Chapter 10. The Long Hibernation. In the deep velvet silence of the Martian night, we reach the final and most profound mystery that the Zhurong rover has laid before us. We have traveled through the roar of ancient floods, the slow retreat of oceans, and the microscopic dance of salty brines. Now let your mind settle into the absolute stillness of the subsurface, a place where time seems to have folded in on itself. As the rover stands motionless under the pale light of the two Martian moons, we begin to contemplate the possibility of the long hibernation. We are no longer talking about the movement of rocks or the chemistry of salts, but the potential for life itself. Tiny, ancient organisms that may have learned the ultimate lesson in patience. Take a slow, deep breath, and as you exhale, we imagine the concept of a biological pause. On Earth, life is a frantic, non-stop process of consumption and reproduction. But on a world that has lost its warmth, life would have to adapt to a different rhythm. Imagine a microbe that once thrived in the shallow, sun-drenched waves of the Utopia Ocean billions of years ago. As the water vanished and the cold set in, this organism didn't simply perish. Instead, it retreated into a state of cryptobiosis, a deep sleep so profound that it borders on the edge of non-existence. It shed its internal water, replaced its fluids with protective sugars and salts, and turned its cell wall into a fortress of glass. It became a biological seed, a tiny capsule of DNA waiting for a signal that might not come for a million years. We'll visualize these billions of seeds scattered throughout the hydrated layers that Zhurong's radar has mapped. They are tucked away in the microscopic pores of the clay, protected from the deadly ultraviolet radiation of the sun by meters of iron-rich soil. They are not living, in the sense that they are not breathing or eating, but they are not dead. They are in a state of suspended animation, a long hibernation that mirrors the cycles of the planet itself. They are waiting for the tilt of the axis, for the return of the great summer, for the brief moment when the perchlorates turn into liquid brine and the temperature rises just enough for the glass to turn back into a cell. As you drift deeper into relaxation, let the idea of this cosmic patience fill your mind. There is something incredibly peaceful about the thought of life that can wait out the eons. It suggests that the universe is much tougher and more persistent than we often believe. Zhurong's discovery of wet minerals only 400,000 years ago is a beacon of hope for this theory. In geological terms, 400,000 years is but a weekend. If the ground was damp that recently, it means the hibernation hasn't been that long. The seeds are still fresh. The biological spark is still there, protected by the chemistry of resilience we explored in the previous hour. Imagine the waking process. When the Milankovitch cycles bring the heat of the sun back to the northern plains, the microscopic films of water begin to expand. The salts dissolve, and a single molecule of water touches the glass-like shell of a hibernating microbe. The shell softens. The proteins inside begin to unfold. After a million years of silence, the internal machinery of the cell begins to hum. It takes a breath of Martian air, processes a single ion of iron or sulfur, and begins the work of repair. For a few centuries, while the tilt is right, this life flourishes in the dark dampness of the sand. And when the cold returns, it simply folds itself back into a seed, ready to wait for another million years. This is the deep pulse of Mars. It is a life that is synchronized with the stars rather than the seasons. Zhurong is the first explorer to map the habitable zones where this pulse might be strongest. By finding the places where the radar echoes are the brightest and the salts are the most concentrated, the rover is essentially creating a map of the planet's hidden biology. And we are looking for the oases of time, pockets of the subsurface where the hibernation is the most likely to be successful. Think about the solitude of these organisms. They are the ultimate survivors of the space race. They have seen the oceans disappear and the atmosphere bleed away, and yet they remain. They are the true owners of Mars. Zhurong, for all its sophistication, is just a temporary visitor, a metallic ghost passing through their silent kingdom. As you feel the support of your bed beneath you, imagine yourself sharing in this deep, restorative sleep. There is no need to act, no need to think, no need to move. Like the Martian microbes, you are simply being held in a state of perfect, protected stillness. The colors of this hibernating world are dark and rich. Imagine the deep reds of the oxidized iron, the pale whites of the sulfate crystals, and the translucent glint of the biological shells. It is a world of shadows and reflections, a place where the light of the sun is a distant memory, but the internal heat of the planet is a constant, subtle comfort. This is the biogeography of the red planet, a map not of where life is, but where life is waiting. Zhurong's presence in Utopia Planitia is a profound act of witness. By documenting the environment of the long hibernation, the rover is telling us that we are not alone in the solar system. We are just operating on a different schedule. The sleeping microbes are our cousins in time, fellow travelers who have chosen a slower, more patient path through the cosmos. The data the rover sends back is a bridge to this alien perspective, a reminder that life is a broad and flexible term, capable of stretching across the billions of years of a planet's history. As we conclude this exploration of the deep sleep, consider the legacy of the rover itself. One day, Zhurong too will enter a long hibernation. Its batteries will eventually fail, its heaters will go cold, and the red dust will begin to cover its golden wings. It will become part of the very landscape it came to study, a silent metallic seed in the desert of Utopia Planitia. But the knowledge it has gathered will live on, a record of the moment when humanity first truly understood the watery, living heart of the red planet. The rover stands still, its work for the day complete. The wind has dropped to a whisper, and the first stars are beginning to appear in the darkening sky. The long hibernation continues all around it, a silent, the microscopic vigil that has lasted for an eternity and will last for an eternity more. We have seen the whole story now, from the oceans to the floods, from the snow to the salts, and finally to the life that waits in the dark. The journey of Zhurong is a journey into the soul of a planet that refuses to die. As the cold of the Martian night deepens, the rover's systems enter their own version of sleep, a quiet state of preservation until the sun rises again. The transition from this final scientific mystery to the end of our journey is a natural fade into the absolute quiet of the cosmos. We have traveled millions of miles in billions of years, and now, like the rover and the microbes beneath it, it is time for us to rest. The story of what China found on Mars is not just a story of discovery, it is a story of belonging. We have found a world that is a mirror to our own, a world that is dreaming of water in a desert of stars. The long shadows of the northern plains have finally merged into a single, seamless blanket of indigo. Our journey across the silent shores of Utopia Planitia is drawing to a close, not with a sudden stop, but with a gentle, fading resonance. As you lie here, perfectly still, imagine the Zhurong rover standing at the heart of this ancient basin, its golden solar panels reflecting the cold, distant light of the Milky Way. The machine has finished its work for the day, its sensors humming one last time before entering a state of deep mechanical meditation. The data it has gathered, the echoes of floods, the ghosts of oceans, and the chemistry of hidden life is now safely stored, a legacy left for the stars. Feel the weight of your body becoming one with the quiet of the red planet. There is no more distance to travel, no more mysteries to solve. The stories of 1.6 billion years ago are tucked away into the layers of the soil, and the soft white frost is once again beginning its nightly descent from the thin air. Everything on Mars is slowing down, settling into the eternal rhythm of the cosmos. The wind has dropped to a mere whisper, a sound so faint it seems to be part of the silence itself. You are drifting now, moving away from the red dust and toward the soft, black void that cradles the planets. In this space between worlds, there is only peace. The worries of the day have become as insignificant as a single grain of Martian sand lost in a vast dune. You are safe, held in the unwavering gravity of a universe that knows exactly how to care for its wanderers. The stars above are steady and bright, guiding you into a rest that is as deep as the Martian canyons and as calm as the ancient sea. Let the slow, cosmic hum of the universe be your lullaby. As the last light of the rover's sensors fades to a soft amber glow, let your own consciousness fade into the darkness. There is nothing left but the breath. Inhale the stillness of the cosmos. Exhale the last of the world's noise. The red planet is dreaming of its water, and now it is time for you to join that dream. Under the watchful eyes of the distant galaxies, you are exactly where you need to be. The journey has ended and the sleep has begun. Follow the silence into the night, softly now drifting further, deeper into the heart of the stars. Sleep in the red silence, sleep in the eternal calm. Good night.